Hey guys, today we're talking about 3-7 secant and cosecant graphs. Okay, sounds harder than it is. It's if you can do sine and cosine, secant and cosecant are easy. Okay, so as a reminder, secant of x equals 1 over cosine of x. So what we're going to do is we are going to graph cosine. We're going to do 2 cycles of cosine. Okay, remember, so we've got our amplitude, so this is for the parent function, is 1, -1. Our sinusoidal graph is at x or y equals 0. Okay, remember with cosine, every critical point starts is by 90. Yeah, -90. Okay, and remember, and what I'm going to do, I want you to have it like do a dash line. Okay, remember it starts high, then it goes to the sinusoidal graph, then low, okay, so we just grabbed cosine, the parent function of cosine. That's a pretty funky line. Okay, now I graphed the parent function, so maybe I should write it. So this is y equals cosine of x, and you can't read what I wrote. Okay, so this is the parent function. Now, since secant is 1 over cosine, it means it's the inverse. So I'm going to graph it in red. When our graph crosses the sinusoidal axis, that is equal to 0, correct? So when cosine of x equals 0, and we're plugging it in for x, it's going to create an asymptote. So whenever your graph of cosine crosses your sinusoidal axis, there's going to be an asymptote. Okay, so there's more asymptotes than the tangent and cotangent. However, it is much easier to graph secant and cosecant, even though it probably doesn't look like it to you right now. And imagine these lines that were straight. Okay, so we just created all of our asymptotes. Okay, and then after that, and I want it thick, there we go, we draw U's. Okay, so you start at the high and you do a U coming off of it. You start at the low here and you draw a U. So there's another U here. Okay, because imagine, since it is the inverse of it, if you were to cover up, let's say, the bottom half of our graph, basically what we're doing is flipping over our cosine, like this little hump here, flipping it over. Okay, so the green is the parent function of secant. Okay, now let's do sine quickly, because secant and cosecant are very familiar, or very similar. Okay, so again, we got y equals cosecant. Let me erase this. Okay, so we have cosecant of x equals 1 over sine of x. Again, we're going to graph our parent function, 90, 180, 270, and 360. 60. Okay, remember sine starts the sinusoidal axis and then goes up. Okay, so what we just graphed was our parent function of sine. Okay, and I want you to do dashed lines like this as well. Same reason why where sine crosses the sinusoidal axis is where the graph equals 0. So sine of x equals 0 at those dots. And then it creates asymptotes because it creates an asymptote. So whenever your graph crosses your sinusoidal axis, creates a asymptote. Okay, from here it's easy. All you do, put a dot at the high, you make U's. And at the low, high and low. And we just graphed it. Okay? Now, I'm going to give you an example of a problem that you're going to be given on Monday. Again, it looks a lot harder than it really is, and I think you'll see that in a minute after we work through it. So we've got y equals -5 plus 12 cosecant pi over 6 x plus 7. Okay? Just because I want y'all to get in the habit of knowing what your A, your B, your C, and your D are, let's go ahead and lift them out. We know our C is -5, our A is 12, our B is pi over 6, and then our D is -7. Okay? While we're at it, let's go ahead and get our D taken care of. Okay, so remember we're talking about sine and cosine, hence our period length is 2 pi, whereas when we're talking about cotangent and tangent, it was just pi. So we're going to take 2 pi divided by pi over 6. Remember, flip the bottom. So you get 2 pi times 6 over pi. Those cancel. Our period length is 12. For our critical points, you divide 12 by 4. So we're going to have a critical point every 3 units. Okay? All right, let's go ahead and get graphing. We're going to graph our C first, which is at -5. Then we're going to graph our amplitudes, so at 7 and -17. Go ahead and graph your sinusoidal axis. Okay? All right. Now, because secant is like our sine value. Oh, I'm not done. Let me stop that real quick. So we go down to -7. And actually, I want to erase. Let me scoot this over. All right, so -7, -4, -1, 2, because I'm adding 3 each time, because that's my critical point distance. 5, 8, 11, and 14. Okay. Now, we're going to graph our sine. For all of our problems, you're going to graph sine and cosine, but we're going to do it with either very lightly or with dashes. So, I'm going to do dashes since I can't do lightly on this. Okay, so remember sine starts at the sinusoidal axis, goes high, sinusoidal axis low. Okay, make your dashed lines. Okay. Just like I said, whenever your graph crosses your sinusoidal axis, there's an asymptote. So there's an asymptote at -7. There's an asymptote at -1. At 5. And at 11. Extend this more. Okay? And I'm going to use yellow. Yeah. So you create a U at the high, opening up. Create a U at the low, opening down. And remember, nothing can cross your asymptote, so just make a U to where it looks like it's almost touching your asymptote. And there you go. That's all you do. Have a great weekend.